In this video, I'll be doing a number theory problem. Consider integers a, b, c, d. Prove that the product of b minus a, c minus a, d minus a, d minus c, d minus b, c minus b is divisible by 12. Okay, so we want to check if the product is divisible by 12. So, let's just set a variable to the product. P will equal to the product. B minus a, c minus a, d minus a, d minus c, d minus b, and c minus b. So, what do we want to show? What to show? We want to show that 12 is a factor of p. Or p is a multiple of 12. So we want to know that, we want to show that at least one of these factors, one of these 6 factors are going to be a multiple of 12. And also note that 12 can be broken down into factors. 12 equals 2. Well, we can do 3 times 4, 2 times 6, or 1 times 12. Well, not 1 times 12. There's no divisibility rule for 1 times 12. But for 2 and 6, it wouldn't be that good, because if you say 2 and 6, well, the divisibility of rule of 6, well, we have to break this down to 2 times 2 times 3. But this will equal to 3 times 4. So you see, if you can prove that the factors of p, like these 6 factors, well, they contain factors of 3 and 4. Like one of them contain a factor of 3, and one of them contain a factor of 4, then we're set to go. Okay, so now, let's deal with the factor of 4 first. Well, also note that the factor of 4, there's actually going to be multiple cases, because a, b, c, d, to make sure that it's divisible by 12, you also want to get that p should be congruent to 0 mod 12. Zero mod 12 means that the remainder of 0 happens, so it's going to be divisible by 12. So now we want to check that b minus a, c minus a, d minus a, d minus c, d minus b, and c minus b, which one of them is going to be divisible by 4. But then note that it's going to be hard to tackle with the difference. So we can tackle the integers separately, a, b, c, and d. And then we can find the difference. Because you see, we are given this to use. Say, if 4 is going to be a factor of p, if 4 is a factor of, not p, b, and 4 is a factor of a, then you can get that 4 is a factor of b minus a. Here's do example. For example, 4 is a factor of 8. 4 is a factor of 12. So 4 is a factor of 12 minus 8. Or 4. Okay. Other words, in a more general term, if a congruent b mod 4, I'm just saying 4 can be any number. It can be n, or a variable. Then you'll get that 4 is going to be a factor of b minus a, or a minus b, same thing. So this is going to be the same as the above example, except for the above example, 8 and 12 are both mod 0, are both congruent to 0. But if you take another example, for example, 6 is going to be congruent to 2 mod 4. So 4 is going to be a factor of 6 minus 2. Okay, knowing this, now let's tackle the ABCD. And for ABCD, for 4, we can have 2 cases, which are at least two of ABCD have congruent remainders. This means that when they divide by 4, the remainder is going to be the same. Then that means that obviously the second case would be that they all have distinct remainders. But let's do the first one first. So, well, just saying, there's a loss of generality, which means that the order doesn't really matter. You can pick any of the 4 integers A, B, C, D. But we can just say that without loss of generality, WLOG, let A congruent B mod 4. And then, using the thing we proved here, we will get that. So 4 will be a factor of A minus B. And then this will mean that 4 will be a factor of P. Because A minus B. Wait, actually here it's B minus A, so we can change this. 4 can be a factor of B minus A. Okay, next one. Case 2 is then going to be if they have distinct remainders. A, B, C, D all have distinct remainders. These will be 0, 1, 2, or 3. Okay, so now note that 2 of these are going to be odd, 2 even. The ones that have a remainder of 1 and 3 are odd. The ones that have a remainder of 0 and 2 are even. Now again, without loss of generality, let A and B be odd. C and D be even. So we can get that B minus A is even. And then, of course, this will mean that D minus C is even. Or in more professional terms, 2 is a factor of B minus A. And then 2 is a factor of D minus C. This will mean that 2 times 2 will be a factor of P. So 4 will be a factor of P. This is pretty obvious because if you have 2 even factors, B minus A and D minus C, the product will be a multiple of 4. For example, if you have here 2 is a factor of 2, 2 is a factor of 4, this will mean that 4 is a factor of 2 times 4. 4 is a factor of 8, which is true. So now we have 4 down. Next, the last case, or kind of prove that it's going to be divisible by 3. But then, usually, an integer divided by 3 will always have the remainders of 0, 1, or 2. But since there's 4 of these integers, this means that at least 2 of them will have the same remainder. Because, there's 4 integers and there's only 3 remainders to choose from. So there's going to be repetitions. So this will mean that at least 2 among A, B, C, and D have congruent remainders. Mod 3. Oh, for the first case, it's going to be mod 4. Okay, so with congruent remainders, this will mean that, again, without loss of generality, let A and B have congruent remainders. So, using this thing here, well, know again that 4 is only for this case, but then 4 can be replaced with 3. So, then 3 is going to be a factor of B minus A. Which then you can get that 3 is going to be a factor of P. Okay. Now, in the first, second, and third case, we can finally get that 12 is going to be a factor of P. And that's how you solve this proof. Key steps is going to be that you have to know that if A is going to be congruent to B mod some number, then 4 is going to be a factor of B minus A, if A is going to be congruent to B mod 4. And then you have to know that you can split 12 into 3 times 4. And you have to know why it's not 2 times 6 instead, because 6 can be broken down further. And well, you see, when we use 4 in this case, it can be broken down to 2 times 2, as shown in the second case. Because if P has 2 even divisors, that means that P is going to be a multiple of 4. And lastly, you have to see that if you have 4 integers, at least 2 of them will have congruent remainders, mod 3. Because 3 has only 3 possible remainders, 0, 1, and 2. And using all 3 of these cases, combine them together, you can get that 12 is going to be a factor of P.